Okay. Hi everyone. I hope everyone is good. So so well I'm so happy to interact and think about new things. Mm, in my previous videos, I've been mm, mentioning the same thing again and again that I'm thinking about information rights and think about technology and its impact in information rights. I mean, naturally, how am I thinking about parallel computing and quantum computing, right? So I mean, what people can, what asynchronous functioning is understanding how we can think about threading in all kind of things where there are multiple processes working for the for functioning of how we can think about different computing techniques in programming. So how it is uh, uh, relate to quantum computing in such a way that we can we can think about a new set of beliefs where there is no control over initially what happens that there is an argument of uh, this supervised and unsupervised learning. Now, I mean, in parallel computing, it is an edge toward understanding how we can think about the knowledge. So this is incredible to see that this is great to see that how we can interrupt knowledge is understand knowledge and not only understand knowledge but to implement knowledge we trying to get perfect understanding of how computers work, right? So this is how it is that we try to interrupt mm, that parallel synchronization techniques for functioning of our input side. This sound a little different, but it is real that that we can think of synchronizing functioning of work where there are multiple threadings and multiple programs that are running simultaneously for a common output, right? So so it is very much natural that these outputs are being configured together for a common purpose. Okay. So so when I see about parallel computing, it comes to the same set of mindset of mind, same set of understanding of mind, where it can be seen that how we can think about functions and how we can think about processing inputs is through parallel threading or parallel computation. In terms of understanding this, there is the knowledge base of of incoherence learning, right? So so it is like you cannot know, but uh, I mean in training synchronization and distribution techniques, we use the quantum computing in inert ways, right? So so I mean I'm not able to relate it properly, but it is I can able to relate it properly to an extent that when we think about computation in mathematical modeling or computation modeling, I think that it is more or less the same thing, that there is an there is an inner line of understanding uh, of the operations of different hardwares or maybe CPU together to find the solutions. So this is how it is that these competition this computation analogy has been has been whispers has been had been been doing simultaneously for a common output, right? Understanding, or when we think about input output understanding, there is an analogy that there is an 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 understanding of model development where we can think about uh, where we can think about the patches, right? So I mean, more or less, it is related to an extent that different techniques of processing input can be related to the mechanics of quantum computing, and that can summarize the parallel computing at the same way. So this is kind of interesting thing. Other than that, there are a lot of other things. I mean, I need to see that. Uh, yes. Well, when I see the clients like in model by itself, right? So how I can see model, and how I can see that the gaps of parallel computing, architecture computing, and quantum computing, right? So it is naturally that I can see that, right? So because I think that we can we can derive the meaning out of that, and this is natural general understanding now, that almost everyone can understand that how we can think about computing when we think about parallel computing, and when we think about asynchronous and synchronous thread processing. So we we derive meaning out of that, right? So we derive meaning out of that, and while driving meaning out of that, there is this thing that we can create model out of that, right? So the client, right? um, like uh, like it is whether it is ChatGPT, whether it is any kind of client, right? So it is there that you can think about clients uh, out of understanding parallel computing, distributed computing, architecture computing, and quantum computing, right? Not really, not to an extent, not really that you can every time you can think about it, but if you can think, you can do it. Why? Because essentially you have to find the meaning. And when people say that there is a difference between financial computing and understanding of financial computing for for the intelligence, for training AI, right? So we can see the recent merger, and we can derive the meaning out of the recent merger, that there may be well, I'm not saying that, but to an extent, if they can believe to quantity value, that quantity values that can derive meaning, it is also possible that we can use them in trading partners and a trading agent. So I mean, naturally, it is a part of understanding that we agent become AI agent, and they can replicate things, right? But is it possible that we cannot control the output and run the parallel threads as we can think about that, right? because because what most interesting thing about intelligence, that we need to find a mechanism to draw for understanding how we can think about computing at a mechanism to draw for understanding how we can think about computing at scale, right? so, so I mean, this is quite a funny, because when we think about computing at scale, we try to derive which is very much natural in doing, right. So yes, I mean, first of all, it is imagination that we think about agents, right? And now we can derive the agents for finding the meanings in the systematic process of quantitative computation, right? That we can think about trading. Okay, I mean, not long ago people can think about trading, but as we process our thoughts, we can come to the conclusion that it is a part of trading also. Okay, so I mean, I'm not amazed to see that it is a part of trading also, but yes, it is an understanding of how we can think about system development, and how we can think about designs, or how we can think about architectural patterns, right? So yes, it is something that that everyone can think about, that in terms of understanding how we can mm, think about distributed computing to a scale and mechanisms of the scale. And when we think about all this architecture in terms of quantum computing. Okay, so I mean, this is kind of interesting thing that that we have been derived from last so many years. Okay, so I mean, I'm personally have started my journey in 2021 onwards, right? So I thought that it may not be complex enough to see the computer science as a discipline, as a separate discipline, right? Initially, I'm trying to learn some of the languages. Naturally, I'm failed toward that. Then I thought that I maybe learn something else. Then again I failed. In 2021, I got breakthrough. I thought, yeah, why why not take a higher risk and do that, right? And yeah, then finally I did that. Okay, but still, at the end of 2003, it is 2023. It is naturally and naturally being considered a no way road for me, because of the fact that I thought that something getting about. Then I thought, then though it is my personality, but it's a part of understanding that what I think about computers and how I can grow as a person. And though it is my personality, but it's a part of understanding that what I think about computers and how I can grow as a person, and create an outview about that. Okay, so it is like, okay, it is not as such, it is not as such, but yes, when I got to know the various branches of AI in in 2022, mid of 2022, I thought nothing much, it's all settled, right? But but again, it comes to the conclusion finally that, you know at this moment I'm confident enough that I can derive meaning out of that. But still, I mean, now it is very much clear that we have this theory of competition in quantum computing, right? So so I mean, this is phenomenal when into 2024 onwards and before 2024, when we think about the mechanism of understanding AI, and soon we think about how we can think about architectural patterns and computational patterns. We derive meaning out of that, right? So that's great to be. I mean, in quantum computing, about a computation for 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 higher order competition for solving higher order problems, right? So that's the one thing, right? Other than that, it may be, it may be consideration of new inventions in the hardware analogy for deriving meaning. Okay, so I mean, I'm curious about semiconductors from the beginning. Not so much. I'm curious about semiconductors from the beginning. Not so much curious about semiconductors from the beginning, but I mean, what I have seen, that the larger impact of mainframe computing is a part of low-level code programming, and it is naturally an understanding of how we can think about hardware, or the hardware which can be respond which is about to which is about to respond, right? And which is respond correctly. Okay, so I mean, which we can see that IoT is there, right? And we can think about the mechanism of IoT in understanding how we can think about hardwares. Again, again, this is like, the part and parcel of circle, where we can think about the knowledge and understanding, and we can think about hardware with a common viewpoint mm, of deriving meaning out of that. But I mean, in quantum computing, it is more or less I mean, kind of thing, to an extent, but I think that more or less it's related to mathematical computation and analog computers, and yes, the mainframe and low code computation, where we can derive meaning out of that. So I mean, it is kind of good thing when we think about computers, we think about there are meaning to the computers, and to to address the problems of related to hardwares and IoT. But I mean, quantum computing surpassed that race, and and uh, and again put that thing in a circle, that what is the derivation of understanding what's the derivation of understanding this thing, that we can create new patterns in terms of understanding, mm, and dealing with the softwares, right? Well, not really to an extent, but I mean, if we can think about too much of knowledge, so we can think about that. We No, not too much knowledge, but the growth of hardware competition. So we can think about a new patterns, or it substra of of how we can think about quantum computing. Right? If we can think about parallel computing, we can think about the architectural and mainstream patterns of computing, right? So, I mean, more or less, it is related. Other than that, it is same, right? There are a lot of things happening, and more or less, it is just a it's a perfection of analogy of synchronous and asynchronous, where there is a parallel and non-parallel threading, which can be seen in distributed computing as a natural, uh, as a natural way to dealing with the programming in system designs, right? Okay, so uh, this is how am I thinking about new. Okay, this is how it is. uh, this is how am I thinking about new knowledge of computing and knowledge, right? New knowledge of computing and quantum quantum computing, right? So that is all. That is all for now. Okay, I thought that I need to share, so I shared that. Thank you so much, everyone.